So, hello, hi everyone, welcome to the Student the Brand. So, hello, hi everyone, welcome to the Student the Brand. So, this is our Siva sir. So, today we are going to discuss about electric current, CBSE Grade 10 Physics. Okay, electric current, electric current, electric current. Okay, so here related to this one, so we have to do problems also. We have to do problems. So, we'll see now. The rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. The rate of flow of charge is called electric current. Okay. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb, and SI unit of charge is SI unit of time is second. SI unit of time is second. Okay. So here you can observe carefully. Okay. So I hope it is very clear to you all. Okay, electric current. The rate of flow of charge is called electric current. SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay, so 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. Okay, now so we can see on one electron 1.6 into 10 power minus 19 coulomb. On one electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb 1 by 1.6 into 10 power minus 19. Okay, so if it is goes up 1 by 1.6 into so 10 power 19, then if you multiply you'll get it. So you'll get it. So 0.625 into 10 power 19. Okay. So if you do this one, we will get 6.25 into 10 power 18 electrons. 10 power 18 electrons. In 1 coulomb, so this many electrons are present. So related to this one, they will ask few questions. Okay, so how they will ask questions, we will see now. So you can observe now. The question is, how many electrons constitute 1 coulomb of charge? So this is the question. How many electrons constitute in 1 coulomb of charge? In 1 coulomb of charge, 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons. Okay, so they will ask this question. And define electric current and SI unit of electric current. Define electric current. So what is the question? Define electric current. Define electric current is nothing but the rate of flow of charge is called electric current. I equal to Q by T. SI unit. Okay, define SI unit of electric current is nothing but, so 1 coulomb of charge flowing through unit cross section area per second is called SI unit of electric current. But define electric current is nothing but the rate of flow of charge. And SI unit of electric current is ampere. Ampere, so small letter we have to write, and symbol is capital A. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. That is nothing but 1 ampere. Okay. State the relationship between 1 ampere and 1 coulomb. State the relationship between 1 ampere and 1 coulomb. 1 ampere is equal to 1 coulomb of charge flowing through through second. Okay. So that is about next one. So related to this, so we will discuss few more questions. Yes. So the charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. So this is the question. So same, whatever we did here, same thing. So we will derive, but question is different. So the way of asking is different. I will write the question, just check once. So now, so you can see here, the question is, so question, the charge possessed, question is the charge possessed by an electron is 1.6 into 10 power minus 19. Okay, coulomb. So find the number of electrons. Find the number of electrons that will flow per second, to constitute a current of 1 ampere. So this is the question. You can observe. So this is 3 marks question. So 3 marks question. 3 marks question. Okay. The charge possessed. Here you need to understand one thing. So here you have to underline the charge possessed by an electron. Okay. So electron here. This one. Find the number of electrons. So number of electrons we have to find out. N we have to find out. That will flow per second to constitute a current of 1 ampere. So here they given current. So I equal to 1 ampere. Right? So now we have to write the formula. So the formula is, you can observe here the formula. So normally we know I equal to Q by T. Q equal to NE. Quantization of charge. Q equal to NE. So Q equal to NE, quantization of charge. Number of electrons are moving in the conductor. So only 1 electron, 2 electrons, it won't flow. There are many electrons were flowing. So that's why number of electrons are moving. So we can see I equal to NE by T. Ne by T. I equal to Ne by T. Okay. So here you can observe. So now I equal to how much? 1 ampere. 1 ampere. 1 ampere equal to N into E how much? 1.6 into 10 power minus 19. Okay. By. So T equal to how much? Here you can see per second. So per second means T equal to 1 second. T equal to 1 second. Per second they mention, no? So T equal to 1 second. So that's why we have to mention here. Now, so N equal to 1 by 1.6 into 10 power minus 19. Okay. So 1 by 1.6 into 10 power minus 19. So 10 power 19 will goes up. N equal to 1 by 1.6 into 10 power 19. Then you'll get, so from here you'll get it. So from this one, this is the formula. This, so from here we'll get it. I equal to Q by T. So Q equal to Ne. Sir, why you are taking Ne? So Ne is nothing but normally inside of the conductor. So inside of the conductor, many electrons are flowing. Only one electron flows. Will you say current is flowing? Only two electrons flows. Will you say current is flowing? Only three electrons flows. Will you say current is flowing? No. So many electrons are flowing, number of electrons are flowing, then only we can say current is flowing. So that's why we are taking, so Q is a quantization of charge, Q equal to Ne. So that's why I equal to Ne by T, I equal to Ne by T. So now from here we can take N equal to 1 by 1.6 is nothing but 0.625 into 10 power 19, then N equal to, so then equal to you'll get N equal to 6.25 into 10 power 18 electrons. 10 power 18 electrons. So this is very, very important. So very, very important. Make sure that you are practicing this one. Okay, so once again, check once here. Check once here. So the charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. To constitute a current of 1 ampere. Okay. So here you can observe. So 1 ampere current is given 1 ampere. And Q equal to Ne. So N into E, number of charges. Okay. So N into E. So here only one electrons are not flowing, right? Two electrons, if only one electron, two electrons if it is flows, we can't say current is flowing. So there are many electrons, many charges are moving inside of the conductor. That's why that is we can consider as a quantization of charge. So Q equal to Ne, Q equal to Ne, I equal to Q by T, I equal to Ne by T. So Ne by T I am taking. So here I equal to 1 and N, and so here you can see 1.6 into 10 power minus 19 coulomb. Okay. So that is about charge of an electron. Then 1 equal to N into 1.6 into 10 power minus 19 by 1. So N we are taking that side 1 by 1.6 into 10 power minus 19. Then we will get here N equal to 0.625 into 10 power 19. And here you can see N equal to 6.25 into 10 power 18 electron. So this is about, okay, so this type of questions they will come, that to 3 marks, for 3 marks, okay, from electric current. So CBSE grade 10 physics. So electric current 3 marks, very, very important topic. So based on this one, okay, this type of questions they will give. So in the exam, so try to practice this type of questions. Okay, so next one, you can see one more question will do. So next, same question. So how they will ask in different kinds. So few more questions we'll discuss. Okay, how much is the charge? Okay, so few more discussions. Okay, let's start. I'll explain later. We will discuss few more questions. Few more questions from this topic. Okay, now we will discuss about electrical elements. Electrical elements. Okay, those are electrical elements. You can see. First one is cell. So this is cell. Positive terminal, negative terminal. Second one is battery. Battery. Positive terminal, negative terminal, battery. And next one, so cell. So single one, if you have positive terminal, negative terminal, if you say that is cell. If number of cells are connected, then we can say battery. And if you are taking switch, this is switch, and the fourth one I am taking here. So you can observe this is the open switch and closed switch. This is open switch and closed switch. So fifth one you can observe resistor. This is the resistor, and sixth one is rheostat, resistor and rheostat. Okay, rheostat can be connected like this, or either you can take like here, or we can also take like this also. Okay, this is the rheostat, rheostat. So resistor. So open switch and closed switch, closed switch, closed switch. Okay, open switch and closed switch. And here you can observe resistor, rheostat. And next one is ammeter. Ammeter. This ammeter. Okay, so seventh one is ammeter. Ammeter. Right. So this is ammeter. Ammeter. So next one voltmeter. Next one voltmeter. Ninth one is so wire joining. This is a wire joining. Wire crossing. Next one is wire crossing. And 11th one is bulb. This is a bulb. Okay. So you can observe here. You can observe. So cell, battery, open switch, closed switch, resistor, rheostat, ammeter. So here ammeter, positive terminal, negative terminal, positive terminal, negative terminal switch. This is so wire joining. Here is wire joining, wire crossing. This is a bulb. Okay, so bulb symbol, bulb symbol. So now you can observe resistor. Resistor is a device which is used to oppose the electric current. A resistor is a device which is used to oppose the electric current in the circuit. So if you connect, so resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current. So rheostat is nothing but which is used to regulate the current without changing the voltage source. So rheostat is nothing but which is used to regulate the current without changing the voltage source. Ammeter is a device. Ammeter is a device which is used to measure the current. Ammeter is a device which is used to measure the electric current. Voltmeter is a device which is used to measure the potential difference. Okay. And wire joining, wire crossing, anyway bulb. So these are the electrical elements. So now we are discussing about electric circuit. Electric circuit. So now we can see electric circuit, continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. Electric circuit, electric circuit, electric circuit. Okay, continuous and a continuous and closed path of an electric current. Okay, so here you can observe this the bulb. This is the bulb, ammeter, and battery, switch. So positive terminal, negative terminal current is flowing, and here you can see this the bulb. Okay, so you can observe. So positive terminal, negative terminal current is flowing. So here you can observe. So a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. An electric circuit. Here there are two types of currents are there. One is conventional current, conventional current, conventional current, and second one is electric current, conventional current, and electric current, electric current. So what is conventional current and what is electric current? Conventional current is nothing but the flow of positive charges. So positive charges are moving from positive terminal to negative terminal like this. So positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. So conventional current is nothing but the rate of flow of charge. The rate of flow of charge. So the flow of positive charges. Flow of positive charges is known as conventional current. Okay. So positive charges. So here you can see electrons are moving. So flow of electrons. So in the conductor. So here conventional current, positive charges will move from high potential to low potential. So here you need to, if you observe carefully, so positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. Conventional current and electric current. Conventional current and electric current. I hope it is very clear. So be careful while learning these points, because very important, at the same time very similar points. So conventional current is nothing but positive charges are moving. Electric current is nothing but negative charges are moving. And here, so they will ask one question: will electrons flow from positive terminal to negative terminal to positive terminal? That is one point. And the second point is, so electrons will flow from high potential to low potential or low potential to high potential. So they will ask that question. Will electrons will move from high potential to low potential or low potential to high potential? Electrons will move from always low potential to high potential. Low potential to high potential. So that is very important. L to high. Okay. So L to high it will goes. So low potential to high potential. So that is about electric circuit. So conventional current and electric current. So based on this one, questions also they will ask. So questions, so we will discuss. So conventional current completed. Next one. So until Ohm's law will discuss. Based on that one, we will. After completion of the topic, we will discuss few questions. Okay, so just go through it. So electric current, electric circuit now. So potential difference and electrical potential. Okay, so numericals also I'll discuss. Okay, so please do like, share and subscribe and share to your friends as much as possible. Definitely will do numericals. I'll explain numericals also. Thank you for asking. So here you can see now we are discussing potential difference, potential difference, potential difference. Okay, so here you can observe potential difference. So what is potential difference? Potential difference is nothing but, so here I am taking the conductor. So this is the point A and this one point B. Okay, so we are taking the positive charge, we are doing some work. We are doing some work to bring unit positive charge from one point to another point within the conductor. So here if you have to understand one thing, potential difference. Potential difference means, so between 2 points within the conductor. Okay, so why I am stressing this point means, so the next term it's related to previous one, related to this one. That's why I am saying here. So potential difference is nothing but work done to bring unit positive charge from one point to another point. From one point to another point, right? So V equal to W by Q. V equal to W by Q. V equal to W by Q. So W is nothing but work. So positive charge, we are doing some work to bring unit positive charge from one point to another point within the conductor. That is a potential difference. Now electrical potential. So as I said, electrical potential. Electrical potential. So here electric potential also simply we can say. Here we are taking, so positive charge is here at infinity. Positive charge is there at infinity. Okay. So we are doing some work to bring positive charge from infinity to the required field. So this is the required field. We are doing some work to bring unit positive charge from infinity to the required field. So we are doing some work to bring same formula, V equal to W by Q. V equal to W by Q. So W is the work. So V is the positive charge. Okay, sorry. W is the work, Q is the positive charge, V is the potential difference, electrical potential. Here electrical potential difference. So we'll denote with the same letter. Okay, so once again, work done to bring potential difference, work done to bring unit positive charge. This is a positive charge, unit positive charge from one point to another point within the conductor. From one point to another point within the conductor is called potential difference. V equal to W by Q. And here one more point. So SI unit of potential is SI unit 1 joule. So sorry, 1 volt. Work is joule. So SI unit of potential difference is SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. So once again here 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. So that is a definition of SI unit of potential difference. So 1 volt equal to 1 joule by 1 coulomb. V equal to W by Q. V equal to W by Q. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. That is called potential difference. So electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. This is the field. So where we need to bring the positive charge from infinity to this point. So this is the field. Okay. So that's why V equal to W by Q. That is electrical potential. I hope it is very clear. So please do like, share and subscribe to Student the Brand if you are new to the channel. Okay. So if you already subscribed, thank you so much. So click on like button. So remaining, share in our groups, ask your friends to join to the class. Live class is going on. Inform your friends, share the link. Okay, so do little bit favor to me. Thank you so much. Okay, so now Electrical potential potential difference, electrical potential. Now we will discuss about Ohm's law. Ohm's law. After that we will do problems, numericals related to this one. Ohm's law. Ohm's law. Ohm's law. So until here we will discuss problems also related to this one. Numericals will discuss. Okay. Oh, thank you so much. So please share in our class group, inform your friends. So I don't know your name. 7456 user ID, last 4 digits. So thank you so much. Please share to your friends, share to your groups. Ask your friends to join to the class. Click on like button and inform to your friends. So ask them to inform to others related to those who are studying 10th class, because from right now, from starting onwards, purely dedicated to physics, this channel. So completely related physics content only I'm explaining, especially grade 10 physics. So continuously, thoroughly I'm explaining. So remaining 11 1, 11 2, grade 11, grade 12 also. So slowly it is coming, and remaining topics. So exclusively for 10th class. So completely we are dedicating. It's working. Thank you so much. So please share to your friends, ask your friends to join, and share to remaining also. So share as much as possible. Thank you so much. Those are supporting, those are encouraging. Uh, so I'm happy. So with that energy, I will continue. Thank you so much for you all. Okay, done. So now, so come to the point. Ohm's law. So V is directly proportional to I. V equal to IR. V equal to IR. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Okay, at a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V equal to IR. Okay, so from here we can also write I equal to V by R equal to V by I. So like that, so many times we can write. Okay, so many forms we can write. So here you can see V is directly proportional to V equal to I equal to V by I equal to V by R equal to V by I. So now materials required, materials required, materials, materials required. Okay, 4 cells. First one, 4 cells, 4 cells. And the second one is nichrome wire. Nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. And the next one, ammeter. Ammeter. And fourth one is voltmeter. Voltmeter. And the fifth one is switch. 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 And the next one is, sixth one is, so 4 cells, nichrome wire, ammeter, voltmeter, switch, connecting wires, connecting wires, connecting wires. Okay, so now you can see here, these are the materials required. Now circuit diagram, so you have to take 4 cells, you have to draw 4 cells. 1, 2, 1, 2, 3, 4. You have to draw 4 cells. And ammeter, and so here you have to draw the resistor. You have to draw the resistor. Resistor. And switch. So voltmeter I am taking here. So positive terminal, negative terminal, positive terminal, negative terminal. So here you can see 4 cells. So I'm connecting like here, and here also I'm connecting, here also I'm connecting, here also I'm connecting. Okay. Now first you have to connect one cell and note down the reading of ammeter and voltmeter. So this is the nichrome wire. First you have to connect one cell. First you have to connect one cell. First you have to connect one cell, and note down the reading of ammeter and voltmeter, and connect two cells, and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay, so 3 cells and 4 cells also, like this. 4 cells, 3 cells and 4 cells also, and mention in the tabular form given below. So this is the tabular form. Here I am taking 1, 2, 3, 4. Serial number of cells 1, 2, 3. Serial number of cells, ammeter, voltmeter, V by I equal to R. So 1, 2, 3, 4, 1, 2, 3, 4. Okay. So here you can see. So after connecting, so I have to observe the reading of ammeter and voltmeter. So ammeter reading is current, voltmeter reading is potential difference. Then you will get V by I equal to R. Okay, so if you draw the graph, VA graph is straight line. So I am taking like this. This is a graph. VA graph is straight line. V on y axis, I on x axis. The graph is straight line. So if the graph is straight line means, so which obeys Ohm's law, the conductors which obey Ohm's law, those are called ohmic conductors. For non-ohmic conductors, the graph is V on y-axis, I on x-axis. The graph is curved. Okay, the graph is curved. So here you can observe, this is the, for ohmic conductor, the graph is straight line. For non-ohmic conductor, the graph is curved. Okay, so I hope it is very clear. Once again, Ohm's law. So at constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to IR, I equal to V by R equal to V by. So coming to materials required. So what are the materials? 4 cells, actually 0.5 volts and 1.5 here nichrome wire length. Okay, so here you are taking. So ammeter, voltmeter, switch, connecting wires. First you have to connect one cell and note down the reading of ammeter and voltmeter, and connect to 2 cells and repeat the process for 3 and 4. Mentioned in the tabular form given below. So this is the graph which gives the ohmic conductors. So this is the graph for non-ohmic conductors. For ohmic conductors and non-ohmic conductors. So this is about Ohm's law, right? Yes. Now, so now we'll do problems. So we'll discuss few problems. Let's solve. So what is an ammeter? How it is connected in a circuit? So ammeter is used to measure the electric current. So it is connected in series combination. Okay, so what does an electric circuit mean? So what is electric circuit? Electric circuit is nothing but, so an electric circuit, a closed and continuous path of an electric current is known as an electric circuit. So name the SI unit of electric charge. SI unit of electric charge is Coulomb. Okay. Next one. So what is the SI unit of potential difference? What is the SI unit of potential difference? Anyone can answer the question. What is the SI unit of potential difference? Volt. Okay. So define SI unit of electrical potential difference. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. Okay. So define SI unit of electrical potential. The question is define SI unit of electrical potential. So that is nothing but 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. Okay. So from one point to another point. So that's okay, fine. So what is meant by resistance of the conductor? So can you say anyone resistance? What is the resistance? Resistance. What is the resistance? Can anyone say what is the resistance? Resistance is nothing but the phenomenon of opposing the electric current. Resistor is a device which is used to oppose the electric current. Here resistance and resistor. This is a resistor. And SI unit of resistance is ohm. SI unit of resistance is ohm symbol. Okay. So here you can observe resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current. Resistor is a device. Resistance is the phenomena. And the SI unit of resistance is ohm. And the symbol for ohm. Okay. So these are the points now. So dear one, everyone, so please do like, share and subscribe to Student the Brand, and try to share to everyone. Ask your friends to join to the class. Okay, so we are discussing the problems too. Okay, I will write one question. Try to do it. An electric source electric source can supply so a charge so coulomb. So if the current drawn by a device drawn by a device is 25 milliampere. Find the time in which the electric source will be discharged completely. Okay, so this is for 2 marks. Very important question. 2 marks question. Okay, so try to solve it. So I'll give time.